Welcome to SOLIDWORKS 2011. This tutorial is going to cover Week 7 concepts that you're going to need to do the Chapter 4 projects. So an overview of the concepts we're looking at is on the screen now. And so we're going to start by looking at a couple of sketch tools that you may have seen before, covering their basic uses, how to apply them effectively when you're drawing a sketch. We're then going to move on to dimensioning tools, in particular putting ordinate dimensions to use, as well as your typical horizontal and vertical dimensions. We're going to look at creating reference geometry, defining planes and axes, and basically what they're used for in a model. And then finally we're going to look at extrusion references, in other words, how to better control your extruded shapes to do some interesting stuff. And finally, some miscellaneous things like how to control part and document settings, material properties, and such. So we're going to start by looking at the review of sketch tools. So just switching to SOLIDWORKS, I'm going to create a new part. And so I want to quickly go over some of the basic sketch tools that we've seen in the past, how to put them to best use, and just so you can review the best practices for making a sketch. So I'm going to create an extruded boss/base on the front plane, and by default we have our origin here. So as I've mentioned in the past, one of the best things you want to do is just create yourself an initial set of center lines at the origin. You won't always need something like this, but you'll often find it useful. At this point, you're ready to do things like mirroring, offsetting, or and whatever other drawing you want. So to use mirroring most effectively, we can look at a simple example. In this case, I'm going to draw a circular feature, and then maybe we'll have an ice cream cone shape coming off of it. I can use my trim tool to cut away the middle. So basically we have a feature on one side of our part here, or on one side of our center line, and we want to quickly move this over and keep it symmetrical. So we can do this with the basic mirror tool. We can see if we select entities and click mirror, it populates this entities to mirror box. We can check copy, which is typically what you want to do, and that says, you know, make a copy versus just flipping the object around the center. And then finally we want to select mirror about the center axis, and if you do everything right, you'll see this yellow preview. So we can see that in this case we have all these symmetry constraints created. So now if I were to dimension this right side here with somewhat arbitrary dimensions for now, let's see, we'll make 0.73, 0.039. You can see I went ahead and filled in the rest of these dimensions. The actual values or dimensioning isn't important at this point, but the idea is that I've only constrained this one side, but the other side is fully constrained because of its symmetry. So this is very powerful because it lets us do and only think about half of the sketch, but complete the other half, and have SOLIDWORKS do that work for us. So in general, this is going to be a principle you want to try and follow, like keep the amount of sketch features that you have to control minimal. The fewer lines and dimensions and such you have to draw, the easier it's going to be to get right, and the fewer errors you'll introduce through, you know, just general human error. So we can also look at the dynamic version of that tool. So we've seen the basic mirror. Now I'm just going to quickly roll back. I'll delete this sketch stuff. Yes, so we don't need that dimension. So if we look in the Tools menu, Sketch Tools, Dynamic Mirror. Now what this effectively does, after we select a center line for the sketch, we see these symbols appear. The Dynamic Mirror basically lets you create lines and sketch objects and have that same mirroring process happen step by step. So instead of waiting till you've drawn your complete object on one side, you can get it piece by piece. Which you prefer is, it's a matter of personal preference, of course. There's no inherent advantage to either one, except that the dynamic one gives you a more alive preview, so especially if you're new to SOLIDWORKS and sketching, it can be a little bit more friendly. So next we're going to look at different arc and line types, just to make sure that we fully understand what's available to us in the sketch palette. So I'm going to start just by going through each of the default options. So typically you have the line tool is going to be your most common. And this, as you might expect, draws sketch lines. You can also, by hitting the A key, toggle to tangent arcs, which is very useful if you're drawing basically the equivalent of a polyline in AutoCAD. And so this lets you draw a line or a smoothed feature. Very, very quick and easy. The line feature is limited to the line feature is just those lines and arcs, but with those two tools you can do 80% of what you need. You can also, in the drop down under line, use center line, which we've already used to draw these guys, and this we can in general use to make construction geometry of any sort. We can also use, if we want to do a shortcut, for some common shapes, we can use corner rectangle or center rectangle to draw boxes. So for example, if I click center rectangle, I anchor the center of my rectangle, and then I can specify where the corner is. And of course you have multiple choices. 3-point corner rectangle might be useful if you need to specify, as the icon suggests, maybe a rectangle that consists of 3 points, but isn't necessarily aligned to one of the axes. So just keep that in mind. It's not a commonly used tool, but it will be helpful in certain circumstances and can really save you time. And so there are other options as well, 3-point center rectangle, parallelogram, etc. Similarly, the general version of that is a polygon here, where we can specify if I want a 7-sided polygon, then I can just draw that directly from a circle, and it will apply all the constraints to get this working. So that's very useful if you're drawing bolt heads or if you're drawing a lot of hexagonal features. You also have this slot feature. So in general, this is very powerful if you spend the time to learn it. I just want to introduce the concept as you can basically define with a single center line the start and end of the center of a slot. So this would be as if you were using an end mill and you plunged on one side and then made a pass and pulled it back out. This is the feature you would get. So next we're going to look at a couple of arcs. So the common center point arc is basic, of course. We start by clicking a center point, we click the first point, and then drag to create the second. This is useful if you're doing standalone arcs. But if you're doing something like a rounded edge on a profile, something like a tangent arc might be better. So this, you basically specify the starting point, and implicit in that is the assumption that the arc is tangent to the line that you start from. So as long as you have a line to start that from, then it's easy to create a tangent arc with an arbitrary radius and endpoint that you just specify with your mouse. I can also, in this drop-down, create a 3-point arc. And 3-point basically means I specify the start, the stop, and then another point that constrains the radius. You'll notice that the radius doesn't come pre-constrained. I can still drag this around. But that lets me create approximately the shape I want without really worrying about the endpoint conditions exactly or what the radius is. So the 3-point arc is very useful for conceptual type sketching, where I'm just drawing a general shape and I don't, and I'm going to go back and add constraints later. So the last two tools we're going to look at in the sketch review is actually we're going to have to create a part, and then we'll go back and create a second sketch on top of this to see the benefit. So I've just created a circle here, and so if I want to maybe create another feature on top of this, let's say a post that comes out of it, I can draw maybe a circle that comes off here, but maybe let's say I want to make this a symmetrical constraint, or sorry, a concentric constraint. I want to draw a circle that's concentric with this guy. Well, I could spend a lot of time like drawing a circle and then clicking this, and then I can add the concentric relation. It's not so bad, but there's another way to do this directly using the offset entities command. So you've seen this used before, but this, we're just going to quickly summarize what it's useful for. So the fast way to use this is pick a face on an object that you want to offset. You specify the direction using the reverse checkbox. You specify a dimension of offset. And you can check or uncheck this add dimensions box. And now you see we have something that it's offset from this edge, it's inherently concentric, and we can directly control its diameter with this feature. If we don't like this dimension, we can delete it. You can add another, a regular old diameter dimension. Like that one. Word of warning though, if you delete that offset dimension, then you do lose that nice concentric constraint. So just keep that in mind. The workflow, generally you want to use offset if you're not going to be creating a sketch that will be modified very much from that initial shape. Alright, so we've covered some arc and line types and miscellaneous sketch tools. Finally, I want to look at the use of patterns and pattern strategy in SOLIDWORKS. So flipping back to our base part here, let's say I'm going to create a whole new shape, just a simple plate, which we can draw with a rectangle on the front plane. And we'll use whatever the default thickness is. And now let's say I want to create a pattern of holes, say a bolt circle. So one way to do this is I can create an extruded cut, create a center line, cross in the middle. So we'll just try and do that vertically. So there's one, and then another here, and now I can draw a circle with respect to this offset here, or maybe I could do it with respect to this point, or wherever I want this bolt circle centered. So let's say I make this cut, go through, that's fine. Now what are my options to pattern this? Well, I can do a circular pattern of my feature, but then one thing it's kind of annoying here is that I don't really have a point to pick as the center of my pattern. I could maybe pick this edge, and then you can see I get this sort of pattern out here, but that's not really all that useful if I want to create a pattern on this face with respect to the geometry. But if I go into Sketch, I have a point, I have a center in my sketch already, so sorry if I place that correctly, I can just directly create this pattern within the sketch using either linear or circular sketch pattern, and I can choose as my reference that center point there. So you can see this is very powerful because I can sketch a center reference, and I don't have to worry about if I have a cylinder or an axis or anything else handy. Using essentially the same settings, the fill, we have the angle to fill, whether we want equal spacing, how many elements. So I could up this, for example, if I wanted more. And you can see that with this sketch, we can then easily add something like a revolved feature, and you see we're done, and now we have this pattern. Very quick and easy. The downside to doing it this way, as you can see, is that the sketch itself becomes very cluttered. We've got a lot of elements here and a lot of sketch geometry, and if I go back to the point where I'm creating my pattern, let's say I accidentally or on purpose decide that I want to have many more elements on this. So 4 fits, but what if I want 12? Well, clearly this isn't going to work, and it's going to complain because this is not a buildable feature. We have all these intersecting arcs, and so we're basically going to have to either deal with a feature that just straight up fails, or otherwise go through a lot of diagnostics. In general, if you're patterning a cut, which is a little bit harder to show, but we can do that. So I took a few moments to expand this part a little bit so that the origin now lies within the body. So we're going to use this plate to illustrate how to do a feature-based pattern using an extruded cut. And so, as I said before, the advantages of something like this are that you can do a very complicated section and basically reduce the amount of clutter in a given sketch while still being able to create a very complex pattern. So I'm going to create this totally arbitrary, somewhat ugly looking feature. So with this sketch, I can create an extruded cut. Let's say through all. And then I can, if I want, create a circular pattern. And so I'm going to need a reference about this. So the easiest way is going to be to create reference geometry using like an axis. I can choose two planes and select the top and right plane. We can see the axis appearing. Hit check. Now we have an axis. And so if I go, I'm just going to drag this below here. So if I go to pattern this guy, I can select the axis. Now we can see that, while 5 may be a little much, I can very easily create a feature pattern based on this. And I can create more than one feature in this group. So for example, if I added fillets to this, which we can do now, so we can see the straight circular pattern has just all those sharp edges. Let's say I go back and add a set of fillets to a few of these sharp edges. Right? Now I have these two guys together in a circular pattern about that axis. And so we can see very quickly I can create complex collections to create a single element and then just pattern the whole thing. This is nice because it means that the sketcher only has to work with one part at a time. They're somewhat independent. And we can see that, cross our fingers, if the cuts overlap a little, it solves. Maybe it's not exactly what we want, it's not what we anticipated, but we can see that this is a valid solution for our part. So just keep that in mind for, so when you're doing patterns, generally you want to do sketch patterns when you're doing a quick pattern of simple features, and a feature pattern when the individual elements are more complex. This is a conceptual part here showing some of the features you're going to see in the caliper body. And that's, you're going to see the need for both reference geometry and later on things like our dimensioning techniques. But the first thing I want to draw your attention to is just this feature here. So this revolve, if we look at the sketch, we can see is drawn on the middle here. And this is based on this plane, which I have hidden. So we created this plane very simply by using, in our features menu, we use the reference geometry tab, click plane, and then we can see that we get to choose a set of constraints that will define a plane. So the easy way is to pick an existing plane, and then you can specify an orientation relative to it. You can specify an offset, which is what we did in this case. And you can also do some other more exotic stuff. But for now, so we just want to choose one of the planes, specify an offset of, in this case, 0.75 inches. That should be enough, and you can see that put plane 2 right on top of plane 1. So that's what we do to get that new sketch reference. Now, if I want to create an axis, it's relatively easy as well. I just click axis and reference geometry. And then I have my choice of referencing schemes. I can choose a cylindrical face, such as this. click the face, hit accept, and now I get the axis at the center of that cylindrical or circular reference. Similarly, I can use two planes, so anything that intersects to create a line, such as these two planes, will produce an axis as well. So there's many ways to do it, and not all of them are immediately useful, but just keep in mind that as long as you can create a straight line geometrically, you can use that to define an axis. Another quick tip I want to mention at this point is that we can use this little tool here, the section view, to get a convenient cutaway of our part to get a better idea of what's going on. And so we can see I've got plane 1 selected as my section plane, and the default settings will cap over this cut feature. So if I click save, now we can see I effectively have a cut through the middle, but this is not a real geometrical cut. Like all these edges you can see still highlight to the original shape. And so this is really nice to be able to see what's going on inside. You can also render views this way as well. So next up, we're going to look at dimensioning tools in a particular sketch. And this is going to be primarily focused on using ordinate dimensioning to simplify doing fine features, and also how do we define cylindrical feature dimensions. So typically ordinate dimensioning, as you should be aware by now, is just a way to specify the position of a feature with respect to some constant origin. So rather than having to draw a whole dimension line with the extension lines and arrows and such, we just have a single marker that says this point is at such and such position. So this is really nice if we have really dense features, of course. And we can see that in action in this part that I've already made. Which one is that? Revolve. So if we go into Edit Sketch, you can see that in our sketch, if I flip this into normal view, it might be easier to see. So we've got these little markers on the top here. Those guys are all done with ordinate dimensioning. And this is very easy to apply, and we can see I can just get rid of them now. If I want to add ordinate dimensions, I just have to go to Smart Dimension, and underneath that there's an ordinate dimension option here. I can also specify horizontal or vertical if I really need to. And then at that point I can just click, so you'll see wherever the first one you place, that's the sketch origin. So in this case I gotta actually redo that origin. So I place my origin, then I can place very quickly a sequence of ordinate dimensions that shows me where all these little stair steps are. And you can imagine that trying to fit arrowheads in all these little gaps, it might not be very conducive to easy reading. So another thing to look at, we mentioned cylindrical dimensions, and we can see that this feature is cylindrical, and I've only drawn half of it in the sketch, but I'm using diameter dimensions to show what each of these diameters are, and using this side view you can get a very clear idea that it's all concentric about this center line here. So to draw a dimension like this, all I have to do is use Smart Dimension, click on a given line, and then the center line, and depending on where I place my mouse, it chooses the type of dimension for me. So if I place the mouse between the two lines, I get the regular dimension you would expect. If I place it off the opposite side, it assumes I want the diameter type dimension. So that's double the distance between these two lines. So this is a very quick and easy way to dimension a complex stepped round feature. And you can see it's very clean to read these dimensions off of the sketch. So the next step we want to look at, in that we'll be putting this to use in the caliper block, is something I like to call like flush extrusion. So this isn't an official name as far as SOLIDWORKS is concerned, but the concept is just you're extruding a feature that's flush along another surface. And so the easiest way to do this is take advantage of some tools that we already know how to use. We can see an example of what that might look like here. So this feature is extruded along this round wall, but it brings a part out. So we have this little nub that comes out, and then we've added a hole. So if I want to make this from scratch, I'll just suppress these now. I can make an extruded boss or base. I'm going to choose this bottom sketch plane, and then use my Convert Entities tool to just select the face and click Done. Now you can see I have this black outline on my sketch that's a great starting point for any feature that I want to have stick out to one side. So let's say I wanted that that part that sticks out, so I can just quickly sketch that with a couple of lines. If I want to round it over, I can use the Sketch Fillet tool or a Tangent Arc tool. Pretty much, it's entirely up to you. And now you can see we have this shape as it would appear, sort of the shadow of that extrusion. Unfortunately, we still have all these other lines which are kind of getting in the way, and so that's going to cause trouble if we try and save it right now. So what I'm going to do is use Power Trim to just quickly cut away all this extra geometry, and you can just kind of wave the mouse around and, in a few seconds get rid of everything extra. Hit check to accept, Power Trim is done. We can see we have a single consistent sketch, and now it's asking what do we want to do with this. So by default it wants to push it up this way, but we can drag this back down and say, okay, extrude along this face. If I hit check, we can see that it fuses into one part. And so this is obviously very nice. We don't have any parting lines here or any gaps like that. So I can also do a few slightly more advanced things at this point. I can change, for example, this to be up to surface. So I can say extrude up to this flat surface, and now I can basically change the shape of this whole feature. It would be as if I edited the sketch, but this way I can preserve that underlying shape. Okay, so now that we've looked at that, I want to quickly look at a slightly more advanced version of this sort of flush extrusion. You can see this feature here, this extrude 7. This guy here, sorry, extrude 4. This is the same basic idea. We've started with edge geometry, and I've added an arc around here. But you can see that I'm offsetting in both directions. So the question is, how do we do that? Well, so there's a very easy setting that I can show you with that feature we just created. It's one subtle change, and that's on this from box. We're used to working down here. We can change this as well. The from box controls where is the starting point of this extrusion. So I can choose the sketch plane, which is the default, or another surface or face. So for example, I could say this face. Now, let's see what happens here. It's probably not going to like this. But we can also choose a vertex, which is less useful. Also an offset from this face as well, which is very useful. So I could add a 0.25 inch offset, and that says go back a 1/4 inch, then start extruding. So I can get, in this case, I can get that nice flush extrusion on the one side and have an offset back here, but still, my sketch is nicely constrained to this plane. So again, it's kind of a matter of preference whether, you could just as easily sketch on this plane and go the other way. But the point is you have a lot of flexibility and choices in how you control your extrusions. So at this point, I've rewound the sketch a little bit to show you what the source of this part looks like, in case you want to recreate this yourself. So we just have a center line with 2 circles, each of radius 0.625, and 2 tangent arcs in between, also with radius 0.625. You can see the equal constraints applied to all 4 of these arcs. So you can very quickly sketch this up yourself if you want to, and if you want to create your own, and then just extrude it up about 1 inch, and you have this basic piece for the caliper plate. Next up, we want to look at some more sophisticated extrusion techniques. And so this is going to help us solve a few problems that you might encounter as your parts get more complex. So in particular, some of the settings that we just saw can control the depth of a cut or how high a boss is extruded to. we can avoid having to specify blind dimensions if we use tune extra up to surface. And you can even cut an extruded hole or boss through another angled face without having to intersect any other features. So this is, before we continue, this is the sketch of an extrusion that I'm going to be using if you want to recreate it. I'm not going to go through how to make it, but you can see all the necessary dimensions here, so just pause the video if you need to draw that. So I have this open. We can see that sketch here again. And I also have here, what you see is just a cut out in this part. This is just enough. It's a 0.2 inch offset from each edge and then a cut line here. So what I'm showing you now is there's two main features that really benefit from these advanced feature tools. So let's look at first the angled hole. And let's say what I want to do is create a hole just through this part and this part, just through the blue surfaces. But it's most convenient for me to sketch this hole on another surface. Maybe this is the source of my geometry. You know, I've got a perpendicular plane, so I want to sketch a hole. I don't want to sketch this ellipse and then have to extrude in another direction. It doesn't work. So here, I can choose that from, again, surface face plane, choose this guy, and now lo and behold, we can do up to surface here. And even though our sketch plane's all the way up here, we can do a hole as if we drilled it just through these two, very nicely controlled without having to have that hole through here. So I accept. You can see that hole that we didn't want through these two passages here is gone. Let's look at another case where maybe I want an extruded feature to blend into an angled face or a round face or anything more complex. You can see if I just use a straight blind extrusion, there's really no good answer. Like I can drag this around, and it's always going to kind of stick out and look ugly. Like it's never going to quite mesh with this thin feature. So the answer again is to use something like up to surface. I can do an extrude up to this top surface. Now we can see it's flush on both sides. Quick and easy. I don't have to specify any dimensions. I could do the same thing if I wanted to go all the way through to the bottom face, for example. And generally, unless this surface has some degeneracy in it around where this feature is, SOLIDWORKS is pretty good at figuring out what this sort of elliptical cross-section has to be to make this extrusion happen. So that's basically all the advanced stuff we need to look at for now. You should be familiar with these other choices as well. For example, mid-plane, you can see, is symmetric about the sketch plane. So that can be nice in some cases, especially if you want to have a reference in the middle of a symmetrical feature. You can also do things like up to body, offset from surface, which is the same idea but just with an offset. So for example, I could say offset here and then do 0.1. Now you can see that there's a gap, but otherwise this feature is still there. So again, this could be very useful in some circumstances, so you just want to keep in mind that capability. So I've pulled up our summary of concepts slide again, so we can see the overview of all the major concepts we've covered in part 1. And finally, I want to take a look at a few miscellaneous part and document settings that you'll find useful. So here you can see, for example, I've changed the color of these faces to make it clear which ones I'm talking about. And the way I can do that is just using this Edit Appearance tool. And here I can select geometry of various types. So for example, if I want to select the whole part, that comes up by default. I can click Remove All Appearances to strip everything out of the way. I can set the whole part as one color. Or I could, if I want to get rid of this selection instead, I can choose individual faces using the face picker, select faces here. And then I can, say, make the top faces just one color. I can do some other stuff here. For example, in the advanced mode, you can do things like surface finish. you could do mapping, etc. But mostly you're just going to need to be able to control the color of a surface. So another thing that will influence the appearance and the behavior of the part in your calculations is the material. You can see this is a standard field in most parts, so if you just right-click on that and click Edit Material, from the library of standard materials you can typically choose hot-rolled steel or stainless, steel, iron, copper, whatever it is. And generally you can see the appearance change subtly. Once you choose a material, the color and sometimes surface texture will change to match that appearance. Finally, we can control drafting properties in a couple places, but the easiest way to customize how dimensions are displayed is in this units grid. This centralizes a lot of information. You can choose the unit system, and also very quickly you can specify the amount of precision for common dimensions. So for example, in inches, often for small mechanical parts you want at least 3 decimal places. So we can specify that here. Do the same for length and such. Hit OK, and now if I pull up a sketch that has dimensions, you can see that unlike before, where we had 2 decimal places, these guys have, a full 3 decimal places of precision. So keep that in mind as you can control your unit properties and those document properties very quickly just by that right-click menu here. And that should be it. So that covers all of part 1. So stay tuned for part 2, where we're going to look into chapter 5 and 6 concepts.